Assalamu alaikum and good day. Our presentation topic is shielded metal arc welding, also known as SMAW, using alternating current. This presentation is prepared for the course welding process and consumable design. This presentation is part of the Diploma of Engineering Technology in Welding, prepared by Group 3 under the guidance of Sir Mohd Yazmi MD Yasan. The group members for this presentation are Nik Muhammad Azharuddin bin Nik Mohd Nasir, Noor Nafal Mukris, and Muhammad Iskander Zulkarnain. Shielded metal arc welding, commonly known as stick welding or manual metal arc welding, is one of the oldest and most widely used arc welding processes in the manufacturing and construction industries. The learning objectives of this presentation are, firstly, to understand the fundamental principles and working mechanism of shielded metal arc welding. Secondly, this presentation aims to explain how alternating current is applied in SMAW and why it is suitable for certain welding conditions. Finally, the presentation will identify the main advantages and limitations of using alternating current in SMAW, helping welders and engineers select the appropriate welding method. This presentation will cover the history of SMAW, the welding process description, SMAW using AC, differences between AC and DC current, welding operation steps, advantages, disadvantages, and conclusion. The history of shielded metal arc welding dates back to the early 1900s and is closely linked to the development of electric arc technology. The earliest foundation of arc welding began in the year 1800, when Sir Humphrey Davy discovered the electric arc during his experiments with electricity. Although this discovery was not immediately applied to welding, it became the scientific basis for future arc welding processes. In 1907, a major breakthrough occurred when Oskar Jelberg developed the first practical coated electrode. The introduction of flux coating significantly improved arc stability and weld quality by protecting the molten weld pool from atmospheric contamination. Shielded metal arc welding was further developed to overcome common welding problems such as oxidation, porosity, and unstable arcs. Its simple equipment design, low cost, and portability made it suitable for fieldwork and outdoor welding. Over time, SMAW became one of the most widely used welding processes in construction, shipbuilding, maintenance, and repair industries, and it continues to be an essential welding method today. In SMAW, an electric arc forms between the electrode tip and the base metal. The arc heat melts both the base metal and electrode core wire. The flux coating melts to produce shielding gas and slag to protect the weld pool. Alternating current is used in SMAW to reduce arc blow, especially when welding magnetic materials. AC current changes direction 50 to 60 times per second and requires electrodes designed for easy arc reignition, such as E6013 and E7018 AC. In direct current, voltage and current flow in one direction only. Meanwhile, in alternating current, the direction of voltage and current changes continuously. The welding operation begins with ensuring proper safety precautions. The welder must wear appropriate personal protective equipment, including a welding shield, safety boots, welding jacket, and gloves. Next, the earth clamp is securely connected to the workpiece to complete the electrical circuit. The correct welding current, or amperage, is then set according to the electrode type and material thickness. The arc is struck using either the tapping or scratching method. During welding, a short arc length is maintained to ensure arc stability and good penetration. The welder must control the travel speed and electrode angle to produce a consistent and uniform weld bead. Finally, after welding is completed, the slag is allowed to cool and solidify before being carefully removed to inspect the weld quality. This video shows an example of a stable welding arc during SMAW using alternating current. Notice how the arc remains consistent and centered, producing a smooth weld bead. The use of AC helps minimize arc blow, especially on magnetic materials, resulting in better weld quality. Despite its advantages, SMAW using AC also has limitations. These include limited applications, lower deposition rates compared to DC, and the need for AC-compatible electrodes. This video demonstrates the effects of arc blow during welding. Arc blow can cause arc wandering, excessive spatter, incomplete fusion, and porosity. These defects reduce weld strength and appearance, which is why alternating current is preferred to control arc blow. In conclusion, shielded metal arc welding is a versatile and widely used welding process. The use of alternating current helps reduce arc blow and improves usability in many welding situations. With proper skill and technique, SMAW using a C can produce strong and reliable welds.